We often talk about AI mastering strategy games, Go poker, things with clear rules. But that next step, true creativity, like
Mhm.
composing something genuinely new, maybe even surprising. Standard AI, well, it often just remixes what it's seen.
It does, and that's precisely why this DeepMind research is so compelling. They tackled creative chess puzzle generation using reinforcement learning. Our mission today really is to unpack how they did it. How do you teach an AI not just to solve, but to create something with that spark of genius?
Right, that's the million-dollar question, isn't it? Be creative isn't exactly an algorithm. You need objective measures. So
Yeah.
how did they formalize something as fuzzy as creativity? What are the key metrics the AI could actually aim for?
They nailed it down to three core aspects. First, uniqueness. A good puzzle has to have one and only one correct solution path. They use the Stockfish engine, a powerful chess AI, to rigorously check that. No ambiguity, no accidental second solutions.
Makes sense. A puzzle with two answers isn't clever. It's just flawed. Okay, so uniqueness. What was next? Novelty. How did they stop it from just, tweaking puzzles it had already seen in its training data?
Yeah, novelty was crucial. They measured it in two ways, basically looking at how different the puzzle position itself was from the training data. They used something called Levenshtein distance on the board setup notation, essentially, how many edits you'd need to make it look like an existing puzzle. And they did something similar for the solution itself, the sequence of moves. Both the problem and the answer had to be genuinely uncommon.
Okay, that's quantifiable. But here's the really fascinating one. Counterintuitiveness. That feeling when you see a move and think, that's terrible. Wait, no, that's brilliant. How on earth do you measure that feeling mathematically?
Ah, that's the secret sauce. They called it the search gap. The idea is human intuition is often like a quick, shallow search. We look a few steps ahead. We might dismiss a move like a sacrifice because it looks bad initially. But a deeper, more thorough search reveals its brilliance.
So the gap is between the shallow evaluation and the deep evaluation.
Exactly. They used a chess engine, comparing its assessment of a move at a shallow search depth versus a very deep one. If a move looked awful shallow, but amazing deep, that creates a large search gap. And that gap became the reward signal for the AI. Bigger gap, more reward.
Okay, so they built this framework. Unique, novel, and counterintuitive via the search gap. Did it actually work? What were the results like?
Oh, the results were pretty dramatic. Rewarding that search gap specifically boosted the generation of these counterintuitive puzzles by 10 times. It jumped from maybe 0.22% in baseline tests to 2.5%. And importantly, that 2.5% was actually higher than the rate found in a large data set of human-created puzzles from liches, which was around 2.1%.
Wow. So it wasn't just generating them, it was generating them more effectively than the baseline human data suggests.
Quantitatively, yes. And the human validation backed it up, too. Expert chess players reviewed the AI puzzles. They rated them as more creative, more enjoyable, and definitely more counterintuitive compared to standard book puzzles.
That's fantastic validation. Right. But, AI optimizing for tricky rewards, did it run into any problems? Any reward hacking, as they call it?
Absolutely. It hit a common RL snag called entropy collapse. The system found a really good high-reward puzzle, and then it just started spitting out tiny variations of that same puzzle over and over again, or got stuck in a rut because that one solution was so rewarding.
Ah, the path of least resistance. So it lost the novelty aspect.
Exactly. It wasn't diverse anymore, so they had to add a fix-it diversity filter. Basically, before getting the full reward, the system checked if the puzzle was genuinely novel compared to recent outputs. That forced it to keep exploring, keep finding new creative patterns.
Right, so you need both the creative spark and a mechanism to ensure variety. Okay, this brings us to the big picture. Beyond cool chess puzzles, what's the broader implication here? Is this search gap idea something we can use elsewhere?
I think that's the most exciting part. This core idea, contrasting a shallow intuitive assessment with a deep ground truth assessment, seems very generalizable. It's a potential blueprint for encouraging creativity in any domain that involves complex search or reasoning. Think about Go, maybe mathematical theorem proving.
Or even large language models?
Potentially, yes. Imagine using this framework to prompt an LLM. You could design tasks or rewards that push it beyond the obvious common answer it might generate first, to encourage it to find solutions or ideas that require deeper, less intuitive lines of thought. It offers a path toward more sustained, maybe even surprising output from AI in complex fields.
A fascinating glimpse into maybe engineering artificial genius step by step. Well, thank you for joining us for this deep dive into AI and the frontiers of creativity. This deep dive was brought to you by embersilk.com. Embersilk is the answer for all your AI education and integration needs. And if you found this discussion valuable, please do subscribe and consider giving us a 5-star review. It really does help us out a lot. Thanks for listening.